Hey everyone, and welcome back to Flutter from Scratch. In today's video, we'll see how you can use the block pattern to query an API in your app. We'll also use a package to check our connectivity, so we can know ahead of time if our API request is likely to succeed or fail, and show a different result depending on whether the device is connected or not. Now, according to previous comments on my videos, there are apparently quite a few guides around this, but they use older versions of Flutter BLOC. So in this video, we'll be using the latest version of Flutter BLOC, which is version 8. Another comment I saw was that it's easier to understand these lessons when I'm coding and typing at the same time, instead of just showing a finished example and then explaining line by line. So in this video, I'll be explaining what I'm doing as I'm doing it. Alright, so let's see how we can use an API in our app that uses Flutter BLOC. So the first thing we'll do is we'll create our sample API project. So of course we have our startup project here that we've come to know and love within Flutter. I'll go ahead and I'll change the project view and I'll open up the pubspec.yaml file and I'll come down to dependencies here and I'll just add in a dependency to Flutter BLOC and equatable. And I'll save that and run pubget. Now for your projects, you probably should set version constraints, but for the purposes of this sample, we'll just take whatever we can get. Just quickly check that log file, and we can see we've got version 8 of BLOC there, which is a good thing. So for our example today, we'll be trying to use this really simple API, which is just called Bored API, as an endpoint for us to query and show the results within our Flutter project. I've chosen this one because the API response is pretty simple and it will show us how we can handle the response while still adhering to the block pattern. The first thing we'll do is we'll just create a very simple UI to show the results of this API call within our UI. So coming into our main.dart, we'll just go ahead and we'll get rid of our my homepage here because we don't need that sample code anymore, and of course that will mean it can't resolve this my homepage widget anymore. But I'll just create a new package and I'll call it home, and again these are just folders even though they're called packages within Android Studio. And here I will create a new Dart file which I'll call home, and I'll create another package called block which will house the block for this widget. I'll go right click and I'll go new block class and I'll just call it home, and I'll tick the equator box and hit OK. Of course that new block class option is given by the Flutter BLOC package for Android Studio. So thinking about what would appear within our UI, we can see this API response here, which I'll just expand a little bit, gives us an activity, gives us a type, gives us a participant count, the price of it, and a certain key, and so on and so forth. So I think within the UI, we probably would like to expose the activity type, what to do if you're bored, and maybe the type, and probably how many participants you would need for that activity as well. So what I'll do now is I'll use QuickType to convert this into Dart, so I can deserialize this API response into my Flutter app. And that's as easy as coming over to the left here, giving a name for our class, and then just pasting in the JSON that we have in that response. And we'll see on the right hand side of the screen some code that looks about right. And then I'll click on options and I'll change Swift to just Dart. We can see here that our code has been generated for us to interact with this API. We have a way to convert from JSON, we have a way to convert back to this JSON, and we also have a class that contains all the things we could need from that Bored API response. So it's pretty handy if you wouldn't like to write it yourself. So we'll go ahead and we'll just select all this and we'll just copy it, and we'll come back into our project and I'll create a new package and I'll call it services, and I'll call this BoredService. And I'll put that in there. One small issue with this converter seems to be that it hasn't been updated for null safety within Flutter, but it's not a total wash. We can just add required in front of all these keywords in the constructor, and that should actually make it work for us. So I'll just go ahead and do that now. Now I've done that and I'll save it. We'll go to problems, and all we have is a warning here. So we can see that as far as Dart's concerned, there isn't anything wrong with this file. So off to a pretty good start. So coming back into the block file here, for our home page, we have our home initial state here, which is probably the state we would load initially with our app, just to show that it is loading or it's querying the API. The second state we'd have here would be the state we have when it's finished loading. So home loaded state extends home state. And hover over that, hit the light bulb, and create the overrides. And for now, we'll just go ahead and we'll just give this an empty list to this equatable override here. As I mentioned before, we probably would like to know the activity name, the activity type, and the participants required. And again, we'll just hover over these lines here, get more actions, and we'll create a constructor for our final fields. We'll also go ahead and add all three properties here to our props list. This is what equatable will use to compare to decide if two objects are equatable or not. Next, we'll hop into our home event and we'll create our load API event. So load API event. Also that extends home event. Again, just hovering over that, and we'll create the missing overrides for that as well. And again, we'll just start with an empty list for now. So we have our states here. We have the initial state here for our home page, which I'll just rename to home loading state actually. So we can see here we have our home loading state, the API request is in flight, and then we have our home loaded state, the API request is finished, and we've got something to display to the user. Our events are super simple. We just have our load API event, which will be dispatched when the user clicks on a button. So now, coming into our home block, we can see here that we'll just change this home initial here to home loading state, because when this block loads up, by default, it's going to be in a loading state. So now what we need to do is we need to send off a HTTP GET request to this board API, and then map the response back to a type of data that Flutter can use. To do that, we'll just go ahead and hop back into our BoredService here, and we'll just scroll all the way down the bottom. And just for this example, we'll make a new class and we'll call it BoredService. So now, because we'll be using HTTP to make a request to the internet, we'll have to come into the pub/spec YAML and add in HTTP as a package. So we'll save that. We'll request our packages from pubdev. So now what we'll do is we'll go ahead and we'll hop back into our service, our BoredService here. And we'll go ahead and we'll create a future, and the future will be of type board activity, and we'll just call it get board activity. In here, what we'll do is we'll use our HTTP package to pass a HTTP GET request to the API, and then deserialize the result and return it back into our block. So now what we'll do is we'll go ahead and we'll leverage this API by passing a GET request by using our HTTP package that we just brought in. We'll reference this board API. We can see here we've got everything we need, the API path as well. So we'll come back into our Android Studio project and we'll just use the URI.pass method and we'll pass in that URI. Of course, as we would expect, this GET request is asynchronous, so we'll need to prefix that with await and also convert this function into an asynchronous function. So after doing this, the contents of this response object will just be the HTTP response, which will obviously include the status code and also the content, which will just be text with the JSON in that. So to deserialize that, we'll just type in final activity equals, and we'll go board activity from JSON, which is a function that came in our automatically generated QuickType code, which is good. We'll go back down the bottom, and in this string here, we'll just give the response.body. And then from here, we can just return the activity. And in those 3 lines, that's pretty much all we need to do to handle the response from the server. We're getting the data from the API, we're deserializing it back into data that Flutter can work with, and then we're returning it into whatever it's called it. So now, let's go ahead and hop back into our block and see how we can wire up some of the business logic for this. Let's go ahead and get rid of this on home event here. I'll add a new event here on load API event, and then of course we have our event emit. So here we're taking an event that's come into our block, and we'll use the emit function to emit out a new state if we have one. As well as that, what I'll do is I'll introduce a dependency on the BoredService here. and I'll hover over the constructor and add a final field for that parameter. In a minute, we'll wire up the dependency injection for this, but just for now, let's take care of handling the event and then producing a new state. So our activity here will just be activity equals BoredService get board activity. And of course it's asynchronous, so we would like to await that and make the calling function asynchronous as well. And then once that's complete, we then would like to emit the home loaded state. Of course, their activity name, activity type, and participants, which will just be activity dot activity dot type, and then activity dot participants. So we're leveraging our service here, and then we're emitting a new state from the data we received from this API. Now what we need to do is we need to go ahead and wire up the dependency injection for this project. So coming back into our main.dart here, we can see from before we have our My Homepage widget, which I deleted. So we'll go ahead and we'll get rid of that line. We'll replace it with a multi-repository provider, and then control space, so we can see that it takes child and providers as possible arguments. So within providers, I'll create a new repository provider, and of course we'll have a context here, and then we'll use that to create the BoredService. And I'll save that and I'll format it a little bit. As well as that, we'll also give it a child element here, which will be our widget that we're just about to create. So if we double click on this home.dart file here, we can see it's totally empty. We'll just make a stateless widget by typing in STLESS in Android Studio and hitting enter. And we'll just call it a homepage. And we'll hover over container and we'll import the widgets library, which will resolve all our dependencies. And then we'll come back into our main.dart here and we'll set the child of our multi-repository provider to just homepage. And I'll go ahead and save that. So our app will load, it'll bring up a multi-repository provider with a single repository provider in it, which is just our BoredService. So this is where all our service registration would go for most block apps. So we'll come into home.dart and we'll change out this container and we'll instead replace it with a block provider, context, and we would like to create a home block. Straight away we can see that because I've created a home block, it's asking where we would like to get the BoredService from. Now that's just what we created that repository provider for. So I'll go ahead and I'll pluck that out of the context that we have. I'll add some commas to get some formatting. And under our block provider here, we'll create a child and we'll just create a scaffold with an app bar. An app bar will have a title, which will just be activities for bored people. I'll save that. And then within our scaffold here, I'll also create a body. And our body will be a block builder because we want the body of this scaffold to respond to what happens in the block. So if it's loading, show the loading UI. If it's loaded, show the loaded UI. And also give the user the option to tap a button to get the next response from the server. Our block builder here takes two type of arguments. It takes a home block and it also takes the home state. We'll then create our builder argument, which will supply a context and also what state is currently coming out of that block. By default, we'll get a little red squiggly line under this curly bracket. That just means that we haven't returned a value. So it could be null and Flutter's warning us about that. For now, I'll just go ahead and just add a container to here. So we are returning something from this function. The first condition we want to accommodate for is if the state is home loading state. And if it's a loading state, then really we'd just like to return a circular progress indicator that's in the middle of the screen. But if the state is the home loaded state, so it's finished loading, then we'd like to display to the user what activity we got from the API, right? So we'd like to return a column because as we know, columns will lay out our data north to south, which is what we would like in this example. And within this column, we'll just have some children, just add a semicolon there at the end of there first. Now, because we've done this type check here to see if it is a type home loaded state, all of the code in this block here, whenever we reference state, it must be of that type because logically that's the only way we can be in this code block. Now, Dart actually knows that, and if we type in state dot, we can see we've got access to all the members of the home loaded state, even though we haven't explicitly converted from one type to the other. So Dart shows some initiative here and gives us access to those properties without us having to explicitly cast that type, which is pretty cool. So we'll use a text widget, and in this text widget, we'll just display the name of the activity along with the type of the activity, along with how many participants are involved. We'll have to call it to string on that because it's a number. The last thing we'd like to do is when this home block first starts up, we would like to send an event into it to tell it to begin loading results from the API. Fortunately, that's as easy as going to the end of this create statement, putting in two dots, typing in add, so sending a new event into that block, and then just calling our load API event, and we'll save that. So with all that done, we'll go ahead and we'll try and build the app, and we'll see how we go. And as we can see there, we have our response from the API. We look at pictures and videos of cute animals, relaxation's the type, and then we can do it with one person, which makes sense. So now what we'll do is we'll go ahead and we'll add a button so people can get another activity from the server. To do that, we'll come back into our lib folder, open up the home folder here, open up home.dart, and then we'll come down to our home loaded state, and underneath our last text object, we'll just add an elevated button. And now what we'd like to do is we'd like to send an event into our block to load the next event. So that's as simple as typing in block provider, because we'd like to resolve the block from our context, and the type of block we'd like to resolve is the home block. Within that block, we'd like to add the event load API event. And for the button itself, we'll just put some text in there and we'll call it like load next, and we'll save that. Add some commas so it formats properly, and that looks pretty good. So back in our code, because I've saved it, I can now just click on load next, and we can see the next API response comes back. But we'll notice that when I hit load next, we'll wait, nothing seems to happen. Then we'll get the next suggestion. This can be a problem if you have like a registration form, and if the users hit the register button, nothing happens, and they click it 5 more times. So what we need to fix this is come into our block here, open up our home block, and we can see here we have our activity where we're waiting, and then we yield the new state. But before we do that, what we'll do is we'll omit the home loading state. So now when someone clicks the button, we'll have our loading state come up, which will show us the circular progress indicator, and then when it's done, we'll have the finished result. So let's see how that looks now. So we'll go ahead and we'll click on that load next button, we'll get our nice circular progress indicator, and as we expect, we have the next activity come in, and so on and so forth. The last thing we'll do is we'll add in a feature for our app, so it can check if our app is offline or not. Then we don't want the user to be able to make the request in the first place, right? Obviously, if our app's offline and a user tries to request an event, then it's not going to work. So to do that, what we'll do is we'll add a dependency on a connectivity plus package, and I'll run pub get to download those packages into our project. So now, what we need to do, we need to respond to the events that this connectivity package gives us. So if we have internet, then we'd like to make a request. But if we don't have internet, then we'd like to tell the user that we don't and they can't make a request. So to facilitate that, the first thing we'll do is we'll go into our library folder here again in services, and we'll make a new service, and we'll just call it connectivity service. We'll make a new class and call it connectivity service. The first thing we'll do is we'll create an object and a new instance of this connectivity package. Now, we want to listen to the connectivity events that occur within this service. So we want to create a stream controller, and the type of that should be connectivity result, which is what we get from the connectivity package. And we'll just call it connectivity stream. And we'll mark it as late because we'll initialize it a little bit later on. Then within our constructor, we will subscribe to our connectivity, which I spelt wrong. We'll subscribe to our connectivity object here, and we'll see here the on connectivity changed stream. And what we'll do is we'll subscribe, we'll listen to this stream, and we'll send all the events that come out of it into our stream controller that we've just set up. Normally in here, if you had a service that did this, you do a bunch of other things. You might save data that was in progress or things like that. But for now, we're pretty much just piping the response of this onConnectivity changed stream into our stream that we just created. So we'll go ahead and we'll save that. And then, because we've created a new service, we need to register that new service as a dependency for our application. So coming back to our multi-repository provider, we'll add another repository provider here. For our connectivity service. And we'll save that as well. So the last thing we'll do is we'll come into our block here, because what we'd like to do is that when the connection status changes, we'd like to tell the user so they can't request anything else from our API. So to achieve that, within our home block, we'll first bring in that service, our connectivity service, and then we'll add it as a constructor parameter. We'll reference that connectivity service here, and we'll reference our stream, and we'll access the stream, and we'll listen to things that are occurring within that stream. So previously we had two states. We had a state where our block was loading, and then we had another state where our block was loaded. But now we have a third state where there's no internet. So because of that, we'll have to go ahead and hop back into this home state file and create a new class and call it home no internet state. And that can extend the home state class as well. The last thing we need to do is we need to hop into our home event file here and add in a new event for the case of there being no internet. So class no internet event extends home event. Then we'll go back into our block. Now, because we have a connectivity stream here and we're listening to it, we can see that every single time a new event comes in, this block will handle the event and can make a decision accordingly. We can now check the result of this event, and if the event result is that there's no internet, then we can add the event that there's no internet event. Otherwise, we can add an event to load the API event. Also add a print statement here so we can understand what's happening. No internet. So that way we can see the result of the stream turn up in our debug console, which would be pretty helpful. So the last thing we need to do here is within our home block here. As we can see here, we're handling the load API event, but you also need to handle the event for when there's no internet. So we can go on no internet event emit, open curly bracket, and then really we just want to omit the no internet state. Add a semicolon there on the end and save that. Now we just need to update the UI so we can see what the user, so we can control what the user sees when there's no internet. To do that, we'll come back into our home Dart, and we can see we have our type check here for what to do if the home is loaded. So just after the end of that curly bracket, we'll just do a type check here for if there's no internet, and then just return a simple text box saying no internet, sad face, and a semicolon on the end. The last thing we'll need to do is hop back into our home.dart here, and we can see that our home block constructor is complaining because we haven't supplied that second service. So we'll add that in now. Repository provider of connectivity service context, and then that'll work okay. So now with that done, we'll go ahead and we'll start up our macOS project. And our app loads up as we'd expect. We can load the next one. If I turn the Wi-Fi off on my laptop, then we can see that it changes to no internet. And if I turn it back on, then of course, then it sends off a new request and it comes through as well. So if I turn the Wi-Fi off, we can see that the state updates accordingly and we get the no internet text here. But if I turn the Wi-Fi back on, then our app appropriately loads in the new event. And that's how, using Block 8, you can interact with an API and also cater for what to do if the connection status of your device changes. So hopefully that video has helped you to understand how you can leverage APIs in your apps when you use the Flutter BLOC package. As always, the source for this example is in the video description you can see below, and don't forget to like and subscribe if this video helped you. And also leave a comment if you have any questions. Thanks so much for watching.